So we have a problem where we have a voltage, and that voltage is applied across three capacitors, and all three capacitors are identical. What I need to do is I need to solve for the charge on all three capacitors, and I need to solve for the total charge. Okay? So I need to figure out how much charge is stored on each one of those capacitors, and I also need to figure out the total charge. Cool? Now, when doing this problem, the first step is actually quite easy. This voltage is across all three capacitors, so I end up with the total capacitance, the total charge that's stored on a capacitor is equal to its capacitance times that voltage. So this Q term here is going to be equal to the capacitance times the voltage, the capacitance times the voltage, the capacitance times the voltage. Okay? In all three cases, the amount of charge that's being stored on each one of those capacitors is going to be equal to the capacitance times the voltage. Cool? Now, the total charge being stored, and because the system is in parallel, not in series, we just simply say the total charge is going to be equal to the equivalent capacitance times the voltage. Okay? That means that the equivalent capacitance is, if I were to replace all three capacitors with one capacitor, that would be the equivalent of those three times the voltage. Well, in parallel systems, that equivalent capacitance is just an additive property. That's the total charge. Okay? Or you could simply just add this charge to this charge to this charge, and you get your total charge. Okay? That only works for parallel systems. It doesn't work for series systems. Okay? So to solve the total charge that's being stored, that's all you have to do. Now, if I were to calculate the energy that's being stored, that's a simple thing. The energy that's being stored is going to be equal to 1/2 times the total charge times the voltage. Okay? So the amount of energy that's being stored in this system is going to be equal to 1/2 the total charge times the voltage. Okay? The equivalent capacitance, I can add all three of them together, multiply it by the voltage, and I get the total charge being stored. And then at each point, it's just the capacitance times the voltage. Cool?